All right, hello class, and welcome to your continuation of your lesson from In Class Today. So where we left off, we were talking about the properties of inequalities. And we had a student demo with Cameron and Jesse, and we were trying to compare who's greater when we perform different types of operations. And every statement remained true that Jesse is greater than Cameron until we divide it by a negative number. And so in our notes here, remember we have when we multiply or divide by a negative number, we must flip the sign. And I kind of want to show you a little more on exactly why that works. So if you would like to follow along, you don't have to add this to your notes, but you certainly can if it's going to help you kind of remember this process, remember the rule. So let's look at inequalities. Let's look at the addition property of inequalities. So I'm going to start with the statement like -3 is less than 2. That's a true statement. Now the question is, does that statement remain true when I add something to both sides? Let's say I add 4 to both sides. Just like I do equations, right? When I add to one side, I have to do to the other. So -3 plus 4, that's 1. And then 2 plus 4 is 6. So yes, that statement is still true, and it checks out. What about subtraction? Let's test out the subtraction property of inequalities. So let's start with that same statement, -3 is less than 2. And let's see what happens when I subtract 5 on both sides. Well, -8 is less than -3. Is that a true statement? Yes, it is, so that checks out. Now let's try this for the multiplication property of inequalities. So let's this time use the inequality -6 is less than 8. What happens if I multiply each side by 2? Will this inequality still remain the same? Well, I get -12 is less than 16. That's still true. All right, let's try with division. Now, if I have -6 is less than 8, if I divide each side by 2, I have -3 is less than 4. Guess what? That's still a true statement, so it works out. So we tested multiplication and division properties of inequalities when we multiply and divide by a positive number. Now, does it still work when I multiply or divide by a negative number? Let's test it out. -6 is less than 8. If I multiply each side of my inequality by -2 this time, negative times a negative is a positive 12, and positive times a negative is a -16. Notice that is no longer true. Okay, so if you write 12 is less than -16, that's a false statement. How do I make sure that the statement stays true? Well, I have to flip the sign. All right. And now it's true. It checks out. Same thing if I take -6 times 8, and let's say I divide each of these by a negative number, -2. Negative divided by negative is a positive. Whoa. Sorry, here's my inequality sign. 8 divided by positive divided by negative is a negative. Notice this is not true. No way. Okay, so what we have to do is I can rewrite these numbers, but I have to make sure I flip my inequality sign. All right, so that's where we got in our notes that when you multiply or divide by a negative number, you must flip the sign. It's really crucial. All right, so let's look at some examples. So to solve, again, the process for solving inequalities is going to be the same as if you were solving the equations. So for here, what you do to one side, again, you do to the other side. Like for instance, you would add 11 on both sides to get n by itself. So we would get n is less than or equal to 31. Make sure you can see this. Okay. But now let's look at a problem. Let's see, like this one right here. To get x by itself, we have to get rid of that -4 in front. To do that, I have to divide each side by -4. Now, I could show this as being divided by -4, but remember, dividing by 4 is the same thing as multiplying by 1/4, and that should be a negative still. These will cancel on the left, so I have x, and on the right side I'm going to multiply across. Alright, so I have x is less than or equal to 3 over -8. However, because I divided by a negative number, this is one of those cases where I have to flip my sign. So x is greater than or equal to -3/8. And so that's how that property works, that rule of solving with inequalities. All right, let's go back to your note sheets. I want to make sure we have this filled out. What is the solution to an inequality? I hope my screen doesn't keep changing on me when I upload this, but all right, you guys. So the solution to inequality is a value that makes the inequality true. So there's some things we should know. The first thing is that an inequality can have more than one solution. So for instance, if you see this inequality, x is less than 3, well, x could be 2, it could be 1, 0, it could also be -5. There are so many possibilities that x can be, okay? So that's what I mean by it has more than one solution. The only solution is not -5. Okay. Next thing you should know is that the set of all solutions, a solution set is the set of all the solutions. This is the solution set. So for example, the solution to an inequality, if you end up with this, x is less than 3, then your solution set will be all the values less than 3, right? And I know I have a third bullet point here. I meant to write this bullet point right here, that a value makes the inequality true. That's what it means to be a solution. What is the solution to an inequality? Well, that's just a value that makes the inequality true. Okay, so that answers this question. All right. The next thing I want to talk about is special solutions. When solving an inequality, the variables might cancel. Dun, dun, dun. So think this is similar to when we are solving equations. Think about you have one solution, you can have no solutions, you can have infinitely many solutions. Something similar can happen with inequalities, okay? So what I wanted you to do is right now, I want you to go to the back side of your worksheet, pause this video, and try examples 13, 14, and 15. And then when you do those examples, come back to this video, and maybe you notice something weird happening. All right? Try it on your own. All right, so for problem 13, Hopefully you are able to solve the inequality as negative 3 is greater than or equal to h. Pull it out. Get rid of the glare. Okay. And we'll talk about how to graph these in just a moment. For number 14, hopefully you got maybe something like negative 8 is greater than or equal to negative 9. Notice those variable terms cancel. So you just end up with the statement and you're thinking, wait a minute, I thought I was trying to solve for y. What happened? Y disappeared. Well, guess what? This is a true statement. So similar to with equations, you might say, oh, this has infinitely many solutions. However, when we deal with inequalities, we're going to use a slightly different wording called all real numbers. Okay? And then number 15, hopefully you notice again that the x's cancel, since that's the same term on both sides of the inequality. But when that happens, notice you end up with something like negative 6 is less than negative 7.5. And that's a false statement. That's not true. So we just say no solutions, just like we say with equations, okay? So really with inequalities, you can have what we call a solution set. You can have all real numbers as your solution where any value, as you see in this number line, any value from negative infinity to positive infinity will work to make this inequality true. Or you could have something called no solutions. So let's go ahead and add this to our notes. All right. So in our notes, you have the special solutions. Now, when solving an inequality, the variables might cancel. When this happens, if you obtain an inequality that is true, then, then the solution is the set of all real numbers. Oh, this is really hard to write and hold my phone at the same time. I apologize. Okay, that's his numbers. Okay, notice this notation right here. It's like an R, except you're going to put a double line there. That's the notation for real. R-E-A-L. Okay? If you obtain an inequality that is false, then the inequality has no solution. Okay, so these could be all real numbers, no solution, or a solution set are the possible outcomes of an inequality. Okay, and last thing we're going to talk about is how to graph inequalities, because your worksheet will ask you to solve the inequalities and then it will provide a number line here for you to graph. So there's a couple things that can happen when we're graphing inequalities. You might, when we will use an open circle. So like, let's just practice. If I have x is less than 3, I'm going to label this as 0, 1, 2, 3. Here, negative 1, negative 2, 4, 5. So you will have to fill out this number line. If x is less than 3, this is 3. X is less than, meaning x can be any of these values over here. To represent this type of solution, we're going to use an open circle. So an open circle is used when the number, put something, the paper won't move. Okay, open circle is used when the number is not a solution. A closed circle, so notice here, x cannot be equal to 3 So I represent that by using an open circle. If you try to put x is 3, that's not a solution. Okay, a closed circle is used when the number is a solution, right? So in this case, if I said x is less than or equal, now x can be the value of 3, so I'm going to shade that in. That's called an closed circle. So let me draw these out. Open circle, closed circle. Okay, and so this we use for the inequalities less than or greater than, and here we use it for the inequalities less than or equal to, or greater than and equal to. Okay. An arrow, when do we use an arrow? Well, an arrow will indicate, this indicates which direction the graph continues. Okay, so if the inequality is less than, you're going to shade to the left. If it's greater than, you're going to shade to the right. Okay, so let's say if x is less than or x is less than or equal to, we are going to go in this direction. If x is greater than or x is greater than or equal to, we're going this direction. What I want you to notice, here's a little trick. Do you see how that inequalities, it almost looks like an arrow is pointed to the left? Well, that's the direction you're going to shade. Here the inequalities point to the right. That's the direction you're going to shade. All right, guys, the last thing we have to note. If all real numbers, if we have all real numbers as our solution, meaning any value on the number line is a solution, what are we going to do? We're going to shade the whole number line. And I'll show you an example of that. So in this example we went over, that's all real numbers. Notice how I even shaded kind of these arrows and I bolded those. The last thing that can happen is if we have no solution, how do I represent that? Notice our example, I didn't do anything to the number line. So we are going to leave the number line blank. Okay, here we go. Do not shade, leave it blank. Okay, you guys, that's all the notes that I have for you for inequalities. I hope that you found this video helpful. And now all that you have to do for your remote stay is solve these problems. All right, thanks for tuning in.